Lesson 5 in topic 6. In this lesson we go on to look at the second factor that affects the rate of reaction, and that is the surface area. This slide, like last time, contains the information about the activities that you need to do. So I want you to think about which has the biggest surface area, the whole potato or the potato chips. And you need to think about what surface area is and how we measure it. Answer on the next slide. So did you guess, or did you get it right, the fact that the chips have a larger surface area? The potato, the whole baking potato, just has the surface area around the outside. Once we cut the potato, all of the cut surfaces also make up the surface area. And this is why chips are actually less healthy for you, because you increase the surface area, and so therefore the more surface area is open to the oil that cooks them. So on this slide is today's title: how does surface area affect the rate of the chemical reaction? So we're going to be looking, like we did in this one, at an experiment that we could do that could investigate the rate of reaction, and then we are going to look at explaining why the rate of reaction is different with different surface areas. So which has the largest surface area, the 2x2 cube or the 1x1 cubes? You need to make sure that you work out the surface area of one face of the cube, and then remember that there are 6 faces on a cube. The exam board, if you were given a question like this, are expecting you to work out the surface areas and not just state your answer. So pause the video here and work out your answers. So the 2x2 cube has a surface area of 24 centimetres cubed, and the 1x1 has a surface area of 48 centimetres cubed. And therefore the 8 cubes of 1x1 obviously have a greater surface area. Now this then takes it a step further, where we look at surface area to volume ratio. So in this case, you will need to work out both the surface area of the cubes and the total volume of the cubes, and you will need to write them as a ratio. And then I would like you to think about how the surface area would affect the rate of reaction. Try and think about collision theory when writing your prediction. The next slide has the answer to the surface area to volume ratios, but we will look at the answer to your predictions once we have done the practical. So to work out the surface area, we do exactly the same as we did before. So for the 4x4 cube, I do 4 times 4 and then times it by 6 because I have 6 faces. To work out the volume, you should do the length times the height times the width. So 4 times 4 times 4. And then I repeated the same for the 8 cubes, but obviously I times the answer by 8 because instead of 1 cube, I have 8. As I said on the previous slide, we will look at whether your prediction is correct once we have done the practical. In this practical, we are going to be using marble chips or calcium carbonate and hydrochloric acid. This reaction produces a gas. The gas produced is carbon dioxide. It also produces water and the salt, calcium chloride. We this time are going to be measuring the volume of gas produced. So we place the chemicals into the conical flask, and then we place the rubber bung with the gas syringe attached onto the conical flask. You need to do this as quickly as possible. Have a think about why. A gas syringe is just like a syringe that they use in the doctor's surgery, except that it is larger and that it is made of glass. It has the measurements on the side, making it an accurate way to measure volume. So having placed the chemicals in and placed our bung on, we would start our stopwatch and time for a minute. Once the minute is up, we would record the volume of gas produced. These are the results from the practical. You'll need to pause the video here so that you can record them. Now, looking at the results that we've got, have a think about what type of graph you could draw from this. You might decide to draw the graph as part of your conclusion. Did you work out which graph you needed to draw? In this case, you would need to draw a bar chart, and this is because you have discontinuous or categoric data. The size of the marble chips is given in words, and this makes it categoric or discontinuous. The other data, the volume of the gas, is obviously continuous because you could have any value in the volume of gas. So you would put the independent variable of the size of the marble chip along the bottom and the dependent variable, the volume of gas, up the side. Which of the marble chips had the larger surface area? You will need to pause the video here and answer these questions, and then we will go on and answer them. The marble chips with the largest surface area is the powder. As we grind it up, we increase the surface area. Using the data, we can tell this because it produces the greatest volume of gas. Thinking about your collision theory, if you have a larger surface area, there is more for the particles to collide with, and therefore you get a greater chance of collision. Think about you hitting a target. If I gave you a very small target, like the clock on the wall at the back of my classroom, you would be less likely to hit it. If I told you to hit anywhere on the back wall of my classroom, you would increase your chances. Did you think about connecting the gas syringe? You need to attach it immediately after adding the chips, as gas is started to produce immediately. One of the biggest sources of error in this practical is the loss of gas, either through a poorly fitting bung, not fitting the bung quickly enough, or just a lack of seal on the delivery tube to the gas syringe. This again is the summary slide for the effect of surface area on the rate of reaction. If you have missed any of these things out, please make sure that you add them in to your conclusion. It's really important, that you make sure that you have an accurate summary. This is a very, very typical question on the exam. I now would like you to have a go at this exam question. This is a graph drawing exam question. The first thing it gets you to do is to draw a graph of the data that they have provided, and they are expecting you to include a line of best fit. Remember that lines of best fit can be curved in science, and you should not always expect it to be a straight line. In fact, rates graphs are generally curved. The second part that it expects you to do is to add a sketch graph. So this means just a freehand sketch on that shows what you would expect it to do if you had smaller marble chips. If you can, please try and do this by hand rather than doing it on computer, as it will make it easier to add on the second line. Pause the video here and complete this part of the exam question. The second part of this exam question gets you to explain in terms of the particles why the rate of reaction changed and also how it changed. Please make sure that you add details about collision theory in an answer to this. It's worth 4 marks, so they are looking for 4 things that you need to have stated. Please pause the video here and complete this section of work. Now it is time to mark your work. You'll notice that drawing a graph is worth 4 marks. Now this is fairly typical for the exam board. They are looking for sensible scales. So have you gone up equally, up the side? They are also looking for all the points being plotted correctly, which is obviously the main thing and therefore is awarded 2 marks. And then they're looking for a line of best fit. As I said, this line should be curved. The second part, where you had to add the sketch, is looking for the line to be steeper, because the smaller the marble chips, the faster the rate of reaction. However, your line should finish at the same overall volume of gas collected. And this is because, although you have changed the size of the marble chips, because you haven't changed the mass, there is still the same amount, the same volume of calcium carbonate chips to react, and therefore the volume of gas should be the same. So in the answer to the second question, they are looking for the fact that the acid particles get used up, and so the concentration of those acid particles decreases. Because of that, you get less frequent collisions, or fewer collisions per second. You will notice that they do not accept fewer collisions, and that's because, as we discussed in the previous question, you will end up with the same number of collisions in total. The qualifying mark is for the fact that you tell me that the rate decreases or the reaction slows down. And finally, I'd like you to have a think about this. Why do we cut up jelly cubes before we try to dissolve them? Think about your key things from this lesson in your answer. And if you've got the stuff at home, you could always have a go. Do half the jelly by cutting it up and the other half of the jelly by just leaving as it is. Does it make a difference? How much longer does it take? I look forward to hearing your answers.